Let's start with the Qualcomm project, QProject. First, we need to create it, give the project a name. We have several options. Either load the library from the computer's hard drive or connect to the phone and load it directly from the device. There's also the ability to view the phone log. There is an advanced gain parser function that allows more precise parsing of gain maps.
Let's start by importing a file.
To import, just select the required library. Either a modern one named according to the pattern com.qti.tuned or one that starts with libchromatics__common. Sometimes the common 0 variant appears. We'll connect to the phone via ADB. In some cases, it's enough to scan the phone by keywords. 2 files were found. IMX179 is the main camera. We check whether the file is suitable. Yes, it's confirmed that the file fits. It's also possible to load a more accurate version of the parser. In this case, the mode is called Advanced Mode. We run the scan and select a file. If we consider the file suitable, choose Use Selected, or we can locate the file manually. Choosing Use Selected starts the parsing. When parsing is complete, click Continue. The program indicates where the file was saved. Now, Library Patcher, Calibration tools and the manual parser are available. Here we see many gain maps. In this window you can load a file. Click Open DNG and choose the 4100K profile. You can also quickly calculate a gain map specifically for this profile, select the Gmap that matches the profile's temperature, and click Calculate. When the calculation is finished, we can save the result as a .bin or write it directly into the library. Click Preview to see how the calibration looks. We can rename any Gmap, for example, to 3200K. The first Gmap is 42K. The third Gmap is 5000K. Then we save the library. You can also create a Magisk module. There's an option to launch Camera Tuner, but it requires setting up rules. For that, use Custom Parser. It will ask whether to open the custom or original library. Having chosen, we open the original library, but we'll pick the custom one. Here you can see where the gain map profile is located for 4100K, 3200K and 5000K. For convenience, you can choose any font and set the number of bytes per group, since we work with float 32, 32-bit, uint 16, 16-bit, or uint 8, 8-bit. In this case, we're interested in gamma profiles. In parser data, it's visible that this is a gamma profile. Values start, for example, around 3615 and then drop. To save the changes, click Save. The edits will be written. Return to Library Patcher. Here you can edit any value and click WR or Restore. To write the file back to the phone, if you have root access, you can use ADB Export, which will push the file straight to the device. There's a Gmap Creator utility. It detects that the current gain map size is 17 × 13. We can open a file and prepare profiles. Next, choose a calibration profile. high, mid, low, or average, compares all at once and finds the best solution. Initially, gain map values are set to 1.0, no gain. We'll start with the simple method, calculate GMAP. The calibration is done, but we see some values below 1. The image is non-uniform. To even it out, use correct map. Now all values are above 1. We check how it looks. The image has become perfectly flat. What else can we do? Choose different gain map sizes. Change black-white levels and select a gamma. For calibration, it's better to use linear, since demosaicing is disabled and colour is uninformative. Any loaded image will look greenish because the CFA has 2 green subpixels. We applied the GMAP. The image became flat. This matters because you can view the image without colorization of pixels. Separately red, green R, green B and blue. There is a special radial point control function. It allows you to calibrate the image in real time using instruments. To do this, choose R input quality, for example 1 to 4, enable the option, select a grey card and use the already loaded GMAP. You can boost the level of a chosen colour. Different algorithm types are available, from 0 to 100%. For example, here is especially 25%. Here is especially 75%. We'll create a point at 75%. Save. Now we can save the generated mask stroke map and use it in further development. Golden Map Editor lets you generate the main camera print profile and load the correct file. You can use Auto Point. The boosted RAW looks noticeably yellow, so we use Auto Balance. This is what the camera's original image looks like. The center is more exposed than the edges. We can correct the edges using Color Shift or use Channel Gain to boost individual channels. In this situation, we use Colorize Corners to compensate for magenta. The ready RAW region can be saved to the Golden folder. A Bayer grid and per-channel viewing are also available. Reference calibration allows you to set up your monitor to create correct temperature presets. You need an external app on your phone and a working camera sensor with the stock optics installed. How it works. There is white, grey and black balance. We start with white. On the phone, we launch an app that shows the temperature of the area. Place the phone on a tripod. Use the sliders to adjust so that the temperature read by the phone matches the value selected in white balance mode. After replacing the optics, reference calibration helps calibrate your sensor and lens. All this information is saved in the project. Back to the patcher. There is a Q-Link feature. It's convenient because with Gain Editor open you can launch Q-Link and the images will update in sync between both programs. We calculated the Gmaps, corrected them. This was loaded automatically into the main program. We changed the temperature and enabled preview. The calibration is applied immediately. Disable Q-Link. Next is an example with a new project. Let's call it Modern. We load the Modern library. We know the file is in lib/64. The process is lengthy. The file is about 90 megabytes. Scanning is complete. We open Patcher and see the number of Gmaps. These are gain maps. And examine what a specific Gmap does. We can see the image hasn't changed much. We generate a new map and check Preview. The image has become flat. In some COM-QTI tuned files, there is a checksum, so it needs to be fixed before saving. The checksum has been fixed. Now you can send the file directly to the phone, create a Magisk module, or simply save the file. Yes, the checksum is correct.